This is a follow-up on forecasting cyclones with astrotometry. It is August 19th, 2010, and I wanted to start out with looking at the 2010 Atlantic hurricane season so far. And NOAA had forecast 14 to 23 named storms, 8 to 14 hurricanes, and 3 to 7 major hurricanes of Category 3 or higher. And this was based on weaker wind shear and warmer temperatures in the region. And we have seen warm water temperatures in the Gulf and the equatorial regions, but we haven't seen the hurricanes that were expected. 2.5 months into the season, we had Hurricane Alex, which was Category 2, and we had Tropical Storm Bonnie, which didn't make hurricane strength. And we had Storm Colin, also, that didn't make hurricane strength, and 2 other tropical depressions that were numbered. And so this has been a very, very weak hurricane season so far. And according to Astrotometry, this weakness is going to continue as long as the deep solar minimum continues. According to NASA, the number of spotless days we've seen as of April 1st, 2009, in this minimum is dating back all the way to 1913. And if you look at the solar cycle cumulatively, if you look at the cumulative depth of this minimum, which has gone since approximately 2006, we haven't seen something like this in almost 200 years. And so this is a very, very deep minimum. And this is the predicted value. This is the revised prediction from the International Space Environment Service. And you can see that the levels that we're actually seeing here, these numbers right here plotted, still aren't making the forecast, even though the forecast has been revised down several times. And what I'm expecting is that the solar cycle is going to continue to lead the formation of the tropical cyclones, and specifically the coronal mass ejections. Presently, NRL is not tracking any storms, and so we don't have any numbered depressions, and we don't have any named storms. So this is sort of an anomalous thing from the perspective of the hurricane forecasters, but in astrotometry it's completely expected, considering the depth of the solar cycle. And so, working from a list of Category 5 hurricanes, I'm going to cross-reference the SOHO data preceding the storm's formation. And since SOHO has only been operating since 1998, we're going to look at just the storms in the 2000s. And Felix and Dean didn't have any SOHO data. And so we're going to be looking at Wilma, Rita, Katrina, Emily, Ivan, and Isabel. So let's take a trip back when the solar cycle was more active and take a look at the time around Hurricane Ivan. Now, Hurricane Ivan formed September 2nd, 2004. And if you look at the SOHO data for around this time, this is on the 30th, you can see that there was a really significant coronal mass ejection that is a lot bigger than the ones that we've been seeing recently. And it's this sort of disturbance that is associated with this cyclonic activity. And you get a better view from this perspective here in the C3 camera. And you can see that this is just a huge disturbance. And you have this shape that is very much indicative of a cyclone that is present visually in the coronal mass ejection itself. There's a very uniform shape to it. And this is what I've come to understand is associated with the larger cyclonic storms, such as Ivan. Another storm that achieved Category 5 was Hurricane Emily in 2005, which formed on July 10th as a tropical depression, and then was actually named on July 11th, Emily. And if you look at the SOHO data from the 9th, you can see that there is a very, very significant ejection. One here first and then here second. And this is probably the one that would associate more closely with a Category 5 event. But if you look at the shape of these two ejections, you can see that there is a sort of asymmetry to the ejection themselves that indicates to me that they are sort of component of the same disturbance, maybe two sides of a particular coin. In other words, the electromagnetic field may have been twisted from both poles, from two different polar directions. And so this is the one that associates with Emily, and we can get a better look at it here in the C2. You can see again, there it's a mass. There's a big chunk of what would be coronal mass. In astrotometry, what this actually is understood to be very, very different than what it looks like. But I'm not going to get into that in this video, and we're just going to stick to the associations of the appearances. Another Category 5 storm was Hurricane Wilma. That was a tropical depression on October 15th, 2005. And Wilma was slow to form and was named Wilma on the 17th, but then didn't achieve hurricane strength until the 18th and 19th. And this sort of thing is reflected in the development of the coronal mass ejections. If you go back to the 17th and look at the protrusions here, you can see that these protrusions already exist for quite a while before there is eventually in the case of Wilma, a very, very large ejection. And these can be seen beforehand in the disturbances of the cloud patterns on the Earth. These can be seen beforehand and tracked as they're forming. They can be aligned and tracked as they're forming. And if you look at the C3 on this, you can see the shape of it a little better as it becomes this sort of telltale sort of cyclonic shape. It has this very, very pronounced edges on the ejection, and this very massive body to it. And so that is the one that associates with Hurricane Wilma. Another Category 5 storm is Hurricane Isabella, that was noticed as a tropical depression on September 6th. Now, if you go back to September 3rd and look at the C2, you can see a very, very large mass ejecting off with this cyclonic shape, these very sharp edges, very, very bright mass. And this is the sort of lumbering, sort of massive disruption that by itself, without interference from other coronal mass ejections, will turn into one of these huge tropical storms. And we can see here the C2 feed on this. You can just see how large that is, and you can see a little better the detail of the magnetic filaments interacting. There's sort of a spiral shape here that sort of weaves out into this more circular shape. And this is the case with all of the large storms that I have examined. There is always this very large coronal mass ejection that is usually not interfered with by one that's on the same side. Sometimes if you see one that ejects from the opposite side, like we saw with, I believe it was Isabella, it seems to strengthen it if an opposing coronal mass ejection. But if there's one that interferes with it in time before it hits, then it can negate it. And again, the amount of mass that appears to be ejected seems to have everything to do with how big the storm is going to be. Another Category 5 storm was Hurricane Rita. If if you go back to September 17th of 2005, that's when we first saw Rita as a tropical depression before it formed into a hurricane. But if you look at the SOHO feed on the 13th, you can see a very, very large coronal mass ejection headed right towards the Earth. And so this was one of those sort of coronal mass ejections where you see the halo of it. You see this is called the halo. And when you see this halo, you know that it's going to influence things fairly significantly. And so you can see it's sort of got that cyclonic shape. We can see it here in the C2. It's just very, very massive sort of ejection that this the CCD that captures the images, that's what you see, the snow, is from the particles hitting the imaging device. And so the imaging device was actually sort of thwarted by the particle storm that came from this more or less Earth-directed CME. And so from that, on the 17th, we got Hurricane Rita. And so this is a fairly clear correlation, I think, here with these very, very large coronal masses and the formation of these sort of superstorms. And last but definitely not least, we have Hurricane Katrina. And Katrina formed as a tropical depression August 23rd of 2005. And the storm's coronal mass ejection could be viewed back on the 21st. There's a huge coronal mass ejection spiraling out. You can see there. You can just see a very, very massive CME there. The density of this ejection, the density is really, really significant in the way that you can see the spiraling happening in the magnetic fields, in the magnetic field lines that are indicated by the way that the plasma is ejecting. And so a few days later, we had Katrina forming in the Gulf of Mexico.